Hello students, I am up now with the videos of our computer science papers. So I am making the first video on the graph theory, which is all about the basic terminologies and the notations. So let's get started. What is a graph? A graph is always going to have vertices and edges. If I say m vertices and n edges, I can write it as m comma n. As you can see this graph, I am having 5 vertices a, b, c, d, e, and I am having 6 edges 1, 2, 3, 4, 5, 6. So I can write g is 5 comma 6. This will be called as order and this is called as the size of the graph. So order of the graph is the number of vertices. I have 5 vertices, order is 5. I have 6 edges, so the number of edges will be the size, that is 6. Now moving forward, what is a self loop? If an vertex is containing edge from itself to itself, it will be called as a self loop. Like for example, here the vertex E is having an edge from E to E itself, right? So E to E we are having an edge, so here we have a self loop. When I talk about multigraph, it is going to have multiple edges. So multiple edges, like if you see this part, the vertex B and C, here a edge is drawn, the straight edge, and the other curved edge is drawn between B and C. As this graph is having multiple edges here between the same vertices, when we have multiple edges between the same vertices, that the resulting would be a multigraph. Okay, so here as I can see that BC is having multiple edges, so it is constituting a figure of multigraph. What do I mean by n vertices? If I consider AB as a edge, so AB is the edge and A and B will be the end vertices for the edge AB. As I say AE is an edge and A and E are the end vertices for the edge AE. When I talk about parallel edges, they are the multiple edges as I have discussed earlier. So here I have parallel edges between B and C. What do I mean by adjacent edges? They are going to have common end vertex. For example, if I take the edge AB and AE, AB and AE are having one common end vertex, that is A. A is coming in both the edges, so this is a common end vertex. So I can say that AB and AE are the adjacent edges. Same way, if I talk about AB and BC, again they are the adjacent edges because they are having common end vertex B. Adjacent vertices. So if the vertices are connected by an edge, I would call A and B as adjacent vertices as I have an edge connecting them. So A and B are adjacent vertices, A and E are adjacent, B and E are adjacent. So that is all about the adjacent vertices. Degree, whenever edges are drawn from a vertex, the number of the edges drawn from a vertex will make up a degree. Okay, so if I have a vertex A, as I can see from A, two edges are drawn, so that is the degree of A, that is D of A I can write, that is equal to 2. Now when I see B, I have 3 edges drawn from it, so that is the degree of B, 1, 2, 3. So degree of B is 3. When I talk about pendant vertex, it means a vertex having degree 1. It looks just like a pendant, only one end connected. So here, whenever I have a vertex with degree 1, I would call it as pendant vertex. So as you can see here, the degree of C is only 1. It is connected to B. So C is a pendant vertex, like a hanging like a pendant. So C is a pendant vertex. When I talk about isolated vertex, it means the vertex is going to have no degree or 0 degree. So here as you can see, D is isolated, very much separate, no edges are drawn from it, hence the degree of D is 0 and therefore this is a isolated vertex. Thank you so much. I will soon upload the video for basic terminologies part 2, where we would discuss some more basic terminologies that are associated with a graph.